So hello guys, today we'll be learning something on stacks and a program on static stacks in C and C++ both. So talking about static stacks, there are basically two types of stacks. One is the dynamic stack, in which we use the concept of linked list, and the other is static stacks, which we'll be covering today, which is based on the principle of arrays. And so you can very well see I started the index with 0, 1 and 2. Well, I'll be explaining all this later. Firstly, what are stacks? Stacks are a type of non-primitive data structures in C and C++, where non-primitive means derived from basic data types, that is int, char, float, just like we have arrays. So it is an ordered collection of elements that works on the principle of LIFO, which is an abbreviation for last in first out. Well, that's an easy way of remembering what stacks are. The simple word LIFO. Explaining it, the element which is entered at the last would be popped out first, that is last in first out. So for an instance, take this diagram. If this was an array, I guess you have to ignore the diagram. If this was an array and the first element enter was A at the index 0, then B at index 1 and C at index 2, that is C was entered at the last, and hence whenever I will call the pop function, the C would be popped out. So one thing is very well clear, that both insertion and deletion can happen only at one end, which I have very well mentioned here. Also, the most important thing which we have here is we only consider one variable, that is top, which I'll be explaining you in this program. And this variable top will decide from where the insertion would take place and where the deletion would take place, and hence you cannot delete a specific element from the stack. So why do we use stacks? Well, if you talk about four functions which are called in each other, say you can take this diagram for an instance. If there was a function A and a function B and a function C, in which B was invoked in A and further C was invoked in B, and so the concept of stack goes, the C function would be invoked first, then the function B would be invoked, and function A would be invoked. Here are stacks used in normal computers. We're talking about in daily life. If you take an example of a stack of CDs, whenever you pile up CDs, the last CD which you piled would be the first CD which you would take out. So that is a real example of stacks, and which is mentioned here as well. So basically there are two operations on stacks. One is push and the other is pop, where push means the insertion and pop means the deletion. And so here is the syntax. I'll be explaining you syntax after the demonstration of this program. So that's a program on stacks on C++ with the extension .cpp, I'm sorry. And here are our header files, in which iostream.h was used for scene and cout functions, and conio was used for getch and the clear screen function. Studio was used for the getS, and the process was used for exit function. So all these are library functions, and so we have to include the header files. And here we go with the demonstration. First the compilation, which shows success, and here we go. So that's a menu driven program which has a do while loop at the in the void main, which I'll be displaying you later. And here select the first option, hitting the enter, pushing the first element, that is 34, continuing, again selecting push 45, continuing, one more element, that is 67, continuing again to the main menu. So before popping the element, first we should have a look at a stack, the stack which we formed, that is displaying the stack, the third option. Here is the stack. Firstly we entered 34, that is on the index 0, then 45 which is on the index 1, and then 67. So it asks want to continue, yes, and then we pop our element. So the element deleted was 67. So it again asks want to continue, yes. Let's have a look at our stack once again. Now it's 45 and 34. Want to continue, no. So now explaining you the syntax, and as I said in the starting of the video, that the variable top is the most important variable here, which is assigned the value of -1. So the question arises, why minus 1? The answer is simple, that the array concept, in the array concept we have the index starting from 0, and hence whenever I'll be pushing an element, I'll start from the index 0. So here if you look at the push function, before inserting the element, that is a top takes the value of num, we firstly increment top by 1, and hence the first element would be assigned the 0th index. And this if condition basically checks if the array or the stack is full or not, and we have the overflow condition. Now it is defined by if top equal to size minus 1. Why minus 1? Because the index started from 0 and it goes from 0 to 19, as we mentioned here, 20. So coming to the pop function, the first condition which we would check that if we have something in our stack or not, that is the underflow situation. So how would we check it? That is if top equal to minus 1, because we initialized top with minus 1, and then before deleting the element we would obviously like to know which element was deleted, and so I took a variable num, assigned it the value in a top. A is our stack, and top is basically acting as a counter where we actually are, and further deleted, and then top minus minus. In actual there is no deletion taking place. This top plus plus and top minus minus basically tells you the termination of the stack, which would be clear from this function, that is display function, where I starts from top, goes till 0, and I minus minus, as it was a reverse loop, so minus minus. So you can very well see that the loop started from top, and whenever we decrement, the size of the array would decrease by 1, and hence one element would be displayed less. And whenever we call the push function, the value of that index would be truncated, and hence we'll be deleting it not physically but logically. And then goes my void main, and I said it was a menu driven program, so here's my do while, all the 4 couts, and then taking an input and the switch cases, just like a normal program. So guys, that's all about stacks, only static stacks, not the dynamic stacks. We'll be covering the concept of dynamic stacks in our next video or in the next article. So remember two most important things in these stacks, concept of stacks, that is LIFO, last in first out, and the position top. These are the two most important aspects of concept of stacks, and these two functions as well, push and pop, where push stands for insertion and pop stands for deletion. Hope I made my points clear on the topic stacks. If you liked the video, do hit the bell icon so as to get notifications on our new videos. Thank you.